Hi everybody. So I feel terrible now for two reasons. One, because I'm really sick right now. It's basically I'm trying to make this video right now before I go to bed for the night because I know I'm not going to be coming into school tomorrow. And the second reason I feel terrible is that not only am I sick, but I feel bad because I haven't seen you guys all week and I've kind of left you now with having meetings on Monday and Tuesday, and now I'm going to be sick on Wednesday. I'm not going to see you guys for a full week, so I really apologize, and I hope that you guys are able to persevere through this. So. I have no idea how your assignment has come along on Monday, Tuesday. I really hope that things went well and you guys feel like you have a good hang of fundamental accounting principle and permutations. But if things didn't go well, then we'll get it figured out next week. But just so we don't lose a day, what I'd like to do here is I'm going to do my very best to make a video on combinations, which is what we were going to do the Monday you guys came back. And so I'd like to flip the schedule around. Rather than having Wednesday be a work day. Assignments aren't due, journals aren't due, scratch all that. We'll take care of that on Monday. I want you guys to watch this video and then work together, especially with kids who already have done this. So Devin and Dakota, I'm looking at you two if you're in the room, hopefully. Work together to try to figure out how to do this next combinations concept. So hopefully this works. I tried making a video for my chemistry class. I made it through about 15 minutes before I got too tired to keep going on. So I'm hoping I can do 15 minutes today, and then we'll talk on Monday, I guess. So I'm sorry, guys. I feel horrible, like I said. So here's the concept. Sometimes when you're arranging objects, it does not matter which order you arrange them in. Order is kind of the key word for the day. And let me illustrate this by using two different examples here, which involve the same thing. Let's say there's 8 teams that get to go to district basketball tournament. In different ways can you medal or award medals for the top 3 teams? Sorry, you guys gotta hang on one sec here.
Well, that's why I asked if you're making a video.
Sorry, guys, just chatting with my wife. Just put it on pause there if you're wondering what the break is for. Okay, sorry, I lost my train of thought. For combinations, say you send 8 teams to a tournament, and we want to figure out how many ways you can award medals to the top 3 teams. We've actually already done this sort of thing before. This would be like, well, here's the first place team, here's the second place team, here's the third place team. How many teams in theory could finish first? Well, 8 teams in theory could finish first. The team that finishes in first can't finish in second, so then there's 7 teams that could finish in second, and then there's 6 teams that could finish in third. The remaining 5 teams, one thing that I would often say a lot is they don't make the cut. Those 5 teams, they don't get a medal. So they're all on the same sort of scenario where you get what I mean. They don't get a medal. So 8 for first, 7 for 6, 7 for second, 6 for third. Oh my goodness. Long story short, we learned last day that you can write this as 8 pick 3. Well, this is a scenario where first, second, and third are all distinguishable items. And that's something we talked about last day, the idea of indistinguishable items, where sometimes you might have 2 items that you really can't tell the difference between the 2 of them because they're identical. For example, this is where we'd use like the letters in the words, like the word puppy, and there's 3 P's in the word puppy. This is what's happening in the next example here. Let's say you go into district basketball tournaments and the top 3 teams go. Well, in this scenario here, although finishing first would be lovely, really all that matters is in this scenario is that you actually get to go to provincials. So the first team gets to go, the second team gets to go, the third team gets to go. But all 3 of the teams that get to go, they all kind of look the same as each other because either you're going to provincials or you're not. So what you could do in terms of writing this out then is you could say, well, there's 8 teams that could finish second and 7 teams that could finish second, I hope I said that right, and 6 teams that can finish third, which we already know that means that it's like 8 factorial divided by 5 factorial. It's that 8 pick notation. But the twist here is that, oh my goodness, that didn't work properly. 8 factorial. Oh, I hope this works out well. Over 5 factorial. The difference here is that the 3 teams that go to provincials, they're all essentially the same as each other. Either you're going to provincials or you're not. So there's 5 teams right here that are not going to provincials. They all essentially look the same. And there's 3 teams that are going to provincials. And they also essentially look the same. And this is essentially the n over ABC formula from whenever I did that last lesson. I guess that was last week Friday already now. So long story short, what you need to be able to discern is whether or not the order matters for distinguishing items. If there's a ranking for first, second, and third, then it's a pick 8, pick 3. But if there really is no order to it, and you have to then divide by the 3 factorial for the teams that are going, there's a different way of doing this. You're going to call this 8 choose 3. And really, it doesn't really make the questions any harder in terms of solving. This is all about interpretation now. You have to interpret whether or not there's a discernible order to the teams who make it or not. If it really is just a case of you're in or you're out, then it's a choose scenario. If it's a case of you're in and we rank you, or you're out, then it's a pick scenario. So let me try some more examples if I can here. For the life of me, I don't remember what I was going for in this particular picture. I'm sure I had a point, but at 12:30 at night right now, I don't remember. So we'll talk about this on Monday. Here's a slide basically then just talking about maybe what I just said. Look, the order of your phone numbers is important. If your phone number is 553, the school phone number I think is 4411. If I type in 5441351 or something like that, I used all the right digits, but they're not in the right order. So that's not a combination. That's a permutation. If order is relevant and like finishing first is different than finishing second, then it's a permutation. But like, if all that matters is just that you get the right numbers in some order, then it's a combination. So, I mean, I use this basketball, volleyball example a lot because I think it makes sense to some kids. If you finish top 2, from what I understand, you get to go to provincials. I mean, obviously you'd love to be first, but hypothetically, if you finish second, you still get to go to provincials. That's an example of a combination where it doesn't really matter whether you're 1 or 2 then. So basically the idea here is that here's the total number of people on that are trying to, I don't know, go to provincials. And you actually have 2 numbers you have to divide by on the bottom. One of the numbers is how many people don't get to go, and the other is how many people do get to go. Okay, so just talk through these examples. Say you got 5 swimmers, 3 get to go on the team. How many possible selections of swimmers are there? Look, you're either on the team or you're off the team. It doesn't matter whether you're first, second, or third. So the answer to this one, I won't write it out because I don't even have my little writing board, by the way. I'm doing this all with the mouse. But the answer to the first one is 5 choose 3. There's 5 people, and we're going to choose 3 of them. Actually, I will write it out. I'm going to try to make this work. 5 choose 3. And by the way, 5 choose 3 really looks like this. There's 5 people on the team. And we were going to break them into 2 groups. 3 of them make the team, and 2 of them don't make the team. The next example here, though, now we're awarding gold, silver, and bronze. Wow, it's still 5 and 3 of them make it. But here, gold, silver, and bronze are individualized. So if you wanted to, you could consider it like this. There's 5 people on the team. There's 1 who gets gold. There's 1 who gets silver. Sorry, guys. There's 1 that gets bronze. And then there's 2 who don't win at all. And it's kind of like the top one up here, only rather than it being 5 over 3 and 2, it's just 5 over 2. And this is what we learned previously. Like this is a 5 times 4 times 3, which is 5 pick 3, like 5p3. Yeah, I'm going to need to speed this up a little bit here because I'm not feeling well. 5 students from class of 10 are chosen to go on a school trip. How many can go? Well, I mean, basically 5 go and 5 don't. So it's 10 choose 5. On this particular one right here, it's 15 choose 3. It's kind of really all the same here. Like I said, your job is to figure out the context. Is it relevant as to what order you're chosen or not? Picture, I'll talk about the pictures later. Boy, I'd really love to do this example right now because I love doing poker examples, but I'm just not feeling good right now, so I might have to skip this slide. So we'll do this on Monday. Okay, I will do this one real quick here. Lotto 649, if you don't know how that works, there's 6 numbers that you select on a lottery ticket out of 49, and the way they make it work is that it doesn't matter what order they are in. If you have those 6 numbers, you win the lottery. So maybe you've heard of the TV show Lost. On the show Lost, there were the numbers 4, 8, 15, 16, 23, and 42. Those were Hurley's special numbers if you've seen that show. Those are his 6 numbers, and it doesn't matter what order they're in. So if he does 42, then 15, then 16, then 8, or whatever the numbers are, then that's fine, just so long as you have the 12. And so I like this comic strip just because it kind of makes fun of people who think they're going to win with the Lotto 649, because basically the way that 649 works is that there's 49 numbers. I'll see if I can write this one out still. 49 numbers, and you need to choose 6 of them in order to win. Now, maybe you even just get an auto lotto ticket and it just randomly picks 6 for you, or maybe you choose your own lucky numbers. But 49 choose 6. This is how many lottery combinations there are. And if you guys grab a calculator and try to find where 49 choose 6 is in your calculator, it's about 13 to 14 million. And since there's one winning combination, your odds of winning a Lotto 649 are 1 in about 14 million. So this will lead really well later in our unit into concept of odds, where we can talk about, well, should you bet on the lottery? Truthfully, from a math point of view, it's probably not worth it for you ever to play the lottery, because statistically your odds are 1 in 14 million. That's not really good. Hypothetically, if you buy a $2 lottery ticket, then unless the lottery is at least worth 28 million, which is double the 14 million odds you have, if it's not worth at least that much money, it's probably not worth your time, because the payoff is not worth the investment concept. So if that made sense, that's great. Basically what I did in my head is I said, if the odds are 1 in 14 million, then if I'm going to pay $2, I better earn 28 million. I basically doubled everything. If I had to pay for a $3 ticket, it better be worth 14 times 3, 42 million. So anyways, we'll talk about that sort of stuff later. So anyways, I hope that helps a little bit. I'm just trying to save some time just because we're losing a day to me being sick now, plus the rest of this week. So I'm sorry I'm not there, guys. I hope this works. What I'd like to ask you to do is persevere as best you can. Like I said, I have no idea how your assignment is going, so I hope it's going well. I hope you feel like you know what you're doing. It's not due on Wednesday anymore. Have it be due on. We'll have it be due sometime next week. We'll figure that out once I'm feeling better. And yeah. So try to take the class today. Look through this combination stuff, see whether it makes sense. Perhaps if the text, if your assignment is just not happening, maybe what you guys could do is maybe try to find your textbooks. Look for the section on combinatorics. I have no idea where it is. I have nothing near me but my computer right now. But see if you can find the section on combinatorics. Maybe just read through those notes that they give there, and maybe try some of the practice examples. I would have loved to have added another page to your journals, but I obviously haven't got to that. So other than that, do the best you guys can, and we'll talk to you Monday. So thanks, guys.